this. And then the note Friday, you like to see me 2 years ago with the mask on. The note video did all of these notes completely. But I'm going to separate this to a video in 2023 of the second part of the notes. Okay, but I do want to recall. I'm going to go back up here. Ooh, these are completely blank. Nice. So I did use these last year. Okay, not quite. But I'm glad I have this too. And maybe back in the old notes, you might want to write this down to impress your teacher next year. That the idea of a recursive and explicit definition, remembering those terms, which very little you will, but those that can memorize these little things. You are going to have a chapter that deals with, arithmetic and geometric sequences and series. Won't tell you what that's about. And if you're in regular CAT, I'm a little scared. We might have to bring that in. We got to find out what the AP exam is going to have on there. If they have that stuff, we might have to change our curriculum a lot. But a recursive definition is the point of Pascal's triangle. What if I wanted to or needed to find the 11th row? To have the 11th row, I would need the 10th. To have the 10th row, I would need the 9th. The 9th row, I'd need the 8th. For me to have the 11th row, I would have to write this thing completely out. All right? And that's not the greatest thing. That's what a recursive definition is. To get the next thing, we would have the previous thing. Otherwise, we have nothing. All right? Whereas the explicit definition, that is a formula that if I need the 11th row, I can plug in a number into a formula and get it. To get the 11th row, though, you got to remember it would be 10C0, 10C1, 10C2, all the way to 10C10. I showed you how to do that on a calculator. 10C brace, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all with commas, close the brace. And then it gives you that Pascal, row for that situation. And then on the board, just to remind yourself, just to get you on the right mind from Friday to now, if you didn't do your homework or whatever, or forget, you had to do a plus b cubed first. I made you go through that pain. You had to do a plus b squared first, then multiply it by a plus b. 1 a squared plus 2ab plus b squared, 1 to 1. And then when you finally cubed it correctly, 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And then you started recognizing patterns. When we finally got to a plus b raised to the 6, we did this pattern recognition to create the binomial theorem in your mind. It's already been created just so you could be introduced to it. Humans recognize patterns. And then when Pascal's triangle was done, they recognized the pattern, how it connects to a binomial being raised to a power. And then notice the A's and the B's, the powers of those shouldn't have to repeat that. A's go down, B's go up. What is B to the 0 power? 3, 2, 1, go, class. 1. So that's why it's not written in that first term. Then we did all these on the notes Friday. Now it's for this, which I like the progression. I like what we were able to do on the board Friday that allowed us to investigate the thing more. And now I'm sitting here without my pen. Did I do any writing during these notes? I'll be back. That's actually good. Usually it's like hard to find. Okay, I'm back. All right, I like these questions better because I am not going to make you go to the 10th power. I'm not going to have you expand this, and that would be 11 terms. That would take like almost a half a period or more. And that's just obnoxious. But what I do want you to understand is, what is the first term? So how do I get to the 5th term? And again, I had people not listening first and third hour, and then person not listening first hour because they were doing their homework, screwed this up right away. All right, so please listen. The first term comes from 10C0 from Friday. First term is the Pascal number coefficient. By the way, that's 1. It always starts with 1, but you need to write that to get this done correctly. And then it's 3x raised to the 10th, negative 2y raised to the 0. That's the first term. So watch my finger. That's the first term. So I need the second, third, fourth, fifth. What's that number right there then? 10C what? 3, 2, 1, go. 4. 0 is the first, 1 is the second, 2 is the third, and so on and so on. This is what robots that don't count, they'll put 10C5 there. You're completely and totally what? Say it. Wrong. I almost put wrong up here instead of term. And now everything kind of falls into place then. What you should recognize in the pattern is this is negative 2y raised to the same thing as this. Do I hear something? What was that? I'm hearing voices in my head. I think somebody's got a technological, or is there someone out in the hallway? I literally just heard something around here, somebody's phone or something. Then 3x raised to the 6th. I don't think I have that thing going on in my computer that something just pops up randomly. So something's going on. Right? What's 6 plus 4, by the way, everyone? 11 or 10, right? 10. Okay. All right. So now go watch my calculator. Oh, no. Why did I shut my calculator down? Let's all awkwardly wait for my calculator to open during the stunning and glorious video that nobody's going to watch. James, I hear you now. Don't start playing games with the old crazy math teacher. All right. So now watch how I did this. Is this right? Is this right? Is that the one? No, that's not the one. So no, that's not right. Is this right? Is that right? Is that correct? What's wrong? Why is this wrong? Why is this wrong? Somebody raise their hand. I can't hear you. I can only hear the voices. You had your hand up. What did you say? What's wrong? Okay, so what should the answer really be? Final answer. Positive. Okay, so you are correct. I liked what you said there. All right, here's the robots. And actually, I'm not kidding. I make mistakes, believe me. You know, like when I said, hey, let's get married. And that's just a joke. That's just a joke. That's just a joke. It's just a joke. Just a joke. Just a joke. Maybe teaching would be fun. Oh, yeah. Oh, no, that's just a joke. Just a joke. Just a joke. Hey, let's have kids. No, that's just a joke. Just a joke. We're gonna cut all that out. We're gonna cut all that out. I just besmirched all 3 major parts of my life. Anyway, what were we saying? Oh, I did not make a mistake here though. I did this on purpose to check my first hour people, you know, and I was messing around with them like, yeah, maybe I'll just do this and see what happens. Then I made a point, those that don't square and do negatives or don't think, a negative to the 4th power is positive. All right. So that's got to be a positive number. So I did do that on purpose. Oh, I admit my mistakes. I make a lot of them. All right. But anyway, that's then you tack that on to x to the 6th, y to the 4th, and I don't feel like writing it. Okay, next one, and then I'll show you the calculator work. This is a lot easier because here's what you really have to look at on this. It's 7c something, and then it's x raised to the something, negative 3 raised to the something, and this gives it away. Find the coefficient that makes it x to the 5th. So what is this right here? What's in the middle? Tell me. 3, 2, 1, go. 5. This is why I like these two, because I don't even want to do this to you. I don't want you to, on a test, although I think on Friday I did do a 7th power one. I don't want a 7th power one written out. We don't have time for that. But I do like these because I can have you find one term, and then that's pretty quick. And then 5 plus 2 is 7, and then that's 7c2. Those match. And I will tell you this. If you write 7c5 here on accident instead of 2, they're exactly the same. Pascal's triangle, the numbers are symmetric, and those are the symmetric pairs. 7c5 is equal to 7c2. Anyone that remembers how to do a combination should know why. And you know what? I'm going to do it. 7c2 is 7 factorial over 5 or 7 minus 2 factorial, 2 factorial. What is 7c5? It's 7 factorial over 2 factorial, 5 factorial for the same reason. Those are identical. That's why it doesn't really matter. But you don't need to know that on this test. You may need to know it next year when they bring up those arithmetic series and sequences. All right. And then this one, again, you got to make sure you type this on your calculator correctly. But all I did was 7C2, which is 21. And then I knew 3 squared negative is 9. All right. So then, and that's 189. And it just wants the coefficient. So that's the answer. So that one I did calculate. And I didn't even bother doing it. I still did it with a calculator. All right, let's move on. And then I do have one added that's a little bit more, got more teeth to it, got more, a little bit more thoughts about exponents. Same thing. This is going to start with 8c something, and then it's 2x raised to the something, 5y. Good thing no negatives here. Raised to the something. All right. Well, it's pretty simple. What is the middle parenthesis? What is that one right there? What goes right here? 3, 2, 1, go. 3. It's the only way you can get x to the third. In this better match, this has to be 5 because 3 plus 5 is 8, and it does. That gives me the y to the fifth term. So this is 8c5 here. All right. So this is why I like these. It demonstrates the formula, but you only have to find one then. I think on that one I didn't even do. No, it's my last one. Okay, so you know how to type it. And then 8c5 times 2 to the third, which is 8, times 5 to the 5, which is 5 times 6, 25. I don't know what that is off the top of my head. But I really like this one. So you can go ahead and type that calculator at this point. You should know how to do it. Maybe on this one I type it. I like this one because it also incorporates just a little bit of exponent rules, which I feel we've been told next year they want us to add exponents and do logarithms next year. We'll see. But we did do a little exponential stuff this year. So here's the question. What is that coefficient? I just got lazy. It's like the last one. What is that coefficient? Well, I know, 12? That'd be 13 terms. But all I know is it's going to be 12c something, 2x cubed something power, and 3y to the fourth something power. And I got to make that larger so it doesn't look like a 0. These are blanks. Okay, class. What would this power have to be right here so that when I raise it to this power, I get x to the 15th? 3, 2, 1, go. 5. This is knowing exponent rules. That's all it is. Knowing that I'm supposed to multiply those. By the way, 12c whatever, 5 plus what equals 12, and then we can check it. What's the answer to that? 3, 2, 1, go. 7, and then is y to the fourth raised to the seventh equal to y to the 28th? Okay, and I made this up out of my mind. I had to make that work, otherwise this is a bogus and invalid question. And by the way, this matches that if you put a 5 there, I could technically mark you wrong because you have an incorrect analysis, but these are symmetric. So 12c5 does equal 12c7. Depending on my mood, I don't know if I'd mark you wrong or not. And then there you go. Did I use the student over there? You keep your name, off the record. Is that the right way to write that now? Yes or no? Yes. But also, what's a negative raised to the seventh, everybody? Negative. So I should have a negative answer when I'm done. So negative, I think that's 55,427,328. So not going to make you write 12 spaces out, but I do absolutely love these questions. Love them. Okay, so 100% calculator.